Alright, in this problem we're asked to graph a piecewise function, two pieces, and this one has a quadratics. Yesterday we learned you can just graph them, but let's just say you're stuck and you can always use a table of values. So on my calculator, I can just put in 2x plus 1. 2x plus 1, and then go to my table of values and just write down some points. So this is my blue graph. Let's just say you don't know how to graph that. You can just get some values here. So -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. Graph that using a pencil. -2, -3, -1, -1, 0, 1, 1, 3. Just trying to show you a different way of graphing this if you didn't see it right away. That's right in slope-intercept form. Starts at 1 up to right 1. Let's graph it. Graph looks like this. Whoops, you guys didn't see me write down the table of values. And then yesterday we learned about having some boundaries. Remember, this is at 1, so this is not a vertical asymptote. But just kind of shows you that I need values are greater than 1, so I need to keep the graph to the right. Remember, when the inequality is on the left-hand side, the variable's on the left-hand side, it's pointing towards the right. Do you see it? So we keep everything to the right of the yellow line. So now you can erase. And are we going to have an open or closed circle? Why is it closed? Because what? It's equals to. Raise your hand if you have a graph that looks like that. Okay. Now for the quadratics, you should just recognize that the parent function is just a quadratic, so it's a u. And +3 just means it's being shifted up 3. Y-intercept of 3. If you didn't see that, you can just put it in there. X squared plus 3. And my table of values, second graph. Write down these numbers. Notice how it's in my second equation for mine, so I'm going to write -2, 7, -1, 4, 0, 3, 1, 4, and then 2, 7. So that just basically means you're taking your x value of 2, put it in here. 2 squared is 4, 4 plus 3 is 7. Okay? Go ahead and graph it. Left 2, up 7, 2, 4, 6, 7. -1, 4, 0, 3, 1, 4, and 2, 7. This is what my graph looks like. And we're going to erase everything to the right, because I want values that are less than 1. Less than 1 is this direction. So, open or close? It's an open because there's no line there. Now we can erase. We learned yesterday that you should not have two graphs over each other. That means you probably graphed it wrong with your inequality. Raise your hand if your graph looks like that. Good job, you. Alright, class, is this a function? Does it pass a vertical line test? Now you're thinking about the jump, right? The infinite discontinuity here. But remember, if I pick a value at 1, this would be undefined. This would be defined. There's a number, so the answer is yes. It's a function. Okay. So how do you evaluate a function? Remember, this is just your x values. What's your y value? What's the order pair? Now, you can do this in two ways. You can do this graphically, or you can do this with algebraically. I'll show you both. Where it says negative 2, where is it true? Is negative 2 bigger than 1, class? Yes or no? No, so I'm not going to use this one. Is negative 2 smaller than 1? Yes, I would put it in here. Negative 2 squared is 4. 4 plus 3 is 7 is my answer. You can also notice this on the graph, negative 2. Where does it intersect at negative 2 here where my pen is? That would be right here. That would be the order pair 2, 7. Remember, that's the order pair negative 2, 7. How about 6? Top or the bottom? Top. 2 times 6? Plus 1? 13. So 6, comma, 13. This one would be kind of hard to see that in our graph. You would have to kind of keep showing where it intersects. Does that make sense? It would be like this. Way up there. And the last one, 1. Top, because it's equals to. So 2 times 1 is, plus 1 is 3. So 1, comma, 3. And you can notice that if you're at 1 here, you're going to go to this one, not here, because that's undefined. This is defined. Okay?